Are we alone? Unraveling the mysteries of the cosmos and the search for extraterrestrial life. What if the universe is teeming with intelligent life, silently watching us from the shadows? Could advanced civilizations be out there, deliberately concealing their existence? Or are they gearing up for a cosmic encounter that could change everything? And what if the key to understanding the universe lies not in carbon-based life like us, but in an entirely alien-form silicon-based organisms thriving in environments we can barely imagine? Buckle up for an epic journey through the stars as we dive into the greatest mysteries of the cosmos, from the mind-bending challenges of interstellar travel to the paradoxes that make us question reality itself. This adventure will take you to the edge of the unknown. Are you ready to explore what lies beyond? In 2025, as humanity stands on the brink of new discoveries, the questions surrounding our place in the universe have never been more pressing. With NASA's Interstellar Mapping and Acceleration Probe IMAP set to launch this year, we are mapping the boundaries of our solar system like never before, probing the interstellar medium that could hold clues to faster-than-light concepts or hidden worlds. Meanwhile, private companies and global space agencies are pushing the envelope on propulsion technologies, making the dream of reaching other stars feel tantalizingly close. But as we'll explore, the path is fraught with scientific hurdles, ethical dilemmas, and philosophical enigmas that challenge our very understanding of existence. Humanity has always gazed at the stars, dreaming of worlds beyond our own. Interstellar travel venturing beyond our solar system has fueled our imagination for centuries, from Jules Verne's tales to modern blockbusters like Interstellar. But is it just a sci-fi fantasy, or are we on the cusp of making it a reality? Thanks to breakthroughs in propulsion, materials science, and our understanding of the universe, we're closer than ever to breaking free from our cosmic backyard. As of 2025, recent advances are accelerating this vision. For instance, researchers at Brown University have developed an ultra-thin, ultra-reflective membrane for light sails, designed to ride laser beams to incredible speeds, potentially slashing travel times to nearby stars by thousands of years. This innovation, detailed in a March 2025 study, could enable probes to reach Proxima Centauri in just decades rather than millennia. Similarly, a groundbreaking proposal from January 2025 suggests beaming matter across space using advanced quantum technologies, making interstellar missions feasible within a human lifetime by reconstructing payloads at the destination. Lockheed Martin's 2025 space technology trends highlight artificial intelligence and machine learning as key enablers, optimizing trajectories and propulsion in real time. Nuclear propulsion is also gaining traction. A June 2025 study from Indian researchers explores fission-powered systems for deep space, emphasizing their financial and logistical advantages over chemical rockets. NASA's own efforts, like the Tracer's mission launching soon, will study Earth's magnetic shield, providing data that could inform shielding for interstellar voyages. Yet, the challenges are daunting. The nearest star, Proxima Centauri, is 4.2 light-years away, a distance so vast that even traveling at the speed of light would take over 4 years. Current technology, like the Parker Solar Probe, reaches speeds of just 0.064% of light speed, meaning a trip to Proxima Centauri would take tens of thousands of years. To make interstellar travel feasible within a human lifetime, we need revolutionary propulsion systems. Concepts like nuclear fusion, antimatter engines, or even harnessing black hole energy are being explored, but they remain theoretical. For example, antimatter propulsion could theoretically propel a spacecraft to 90% of light speed, cutting the journey to Proxima Centauri to just over 4 years. However, producing and storing antimatter is insanely complex and costly. Scientists at CERN create just nanograms of it annually, far from the tons needed for a mission. Then there's the fuel problem. Traditional rockets require massive amounts of fuel, but more fuel means more weight, slowing the craft down. Innovative solutions like solar sails, which harness sunlight for propulsion, or ion engines, which are more fuel efficient, are being developed. Yet, even these require breakthroughs to achieve the speeds necessary for interstellar voyages. The question remains, can we overcome these hurdles in our lifetime, or will interstellar travel remain a distant dream? As Reddit discussions in 2025 note, with current tech, it's very close to unthinkable, but unprecedented advancements could change that. A NASA scientist is even working on warp drive concepts under DARPA wraps, hinting at potential game changers. Expanding on propulsion, let's delve deeper into light sail technology. The 2025 breakthrough from Innovation News Network describes how light sails could revolutionize exploration by using laser arrays on Earth or in orbit to push lightweight probes at relativistic speeds. Imagine a fleet of tiny spacecraft, each weighing grams, zipping toward Alpha Centauri at 20% light speed, arriving in about 20 years. Challenges include maintaining laser focus over vast distances and protecting the sail from interstellar dust, but simulations show promise. Meanwhile, the discovery of a new interstellar object, 3i Atlas, imaged by NASA in August 2025, reminds us that the cosmos is dynamic. Objects like this could serve as natural testbeds for propulsion ideas. World Economic Forum's 2025 report on space tech lists 12 transformative technologies, including advanced communications and space mining, which could fund interstellar efforts by extracting resources from asteroids. Michio Kaku's ongoing work on the physics of interstellar travel predicts Earth-like planets could be discovered within 20 years via NASA's Space Interferometry satellite. Trends from LEAP emphasize commercial growth and new launch vehicles, potentially making interstellar precursors like Oort cloud missions viable by mid-century. However, as a Reddit thread calculates, leaving the solar system fully beyond the Oort cloud might take centuries even with advanced tech. Navigating the cosmic void. Challenges and innovations. Even if we solve propulsion, navigating the vastness of space poses another colossal challenge. Interstellar distances mean communication delay. Signals to Proxima Centauri would take over for years to reach Earth, making real-time contact impossible. Spacecraft would need advanced AI to navigate autonomously, using cosmic landmarks like pulsars rotating neutron stars that emit predictable radiation beams as celestial GPS. But even the slightest miscalculation could send a spacecraft millions of miles off course. Radiation is another deadly threat. Beyond Earth's magnetic shield, cosmic rays and solar flares bombard travelers with harmful radiation, risking cancer and genetic damage. Shielding solutions, like lightweight magnetic fields or advanced materials, are being researched, but they must balance protection with weight. Meanwhile, debris and micrometeoroids traveling at high speeds could puncture a spacecraft, requiring sophisticated detection and deflection systems. The cosmos is a treacherous frontier, and every mission will demand unparalleled precision and resilience. In 2025, advancements in quantum communications offer hope. One promising idea is using entangled particles for instantaneous data transfer, bypassing light speed limits for navigation signals. NASA's IMAP will provide crucial data on interstellar particles that could interfere with navigation. Additionally, AI-driven systems from Lockheed Martin could predict and adjust for gravitational perturbations from unseen black holes or rogue planets. Expanding this section, consider the role of interstellar objects like 3i Atlas discovered in 2025. These visitors from other stars could carry data on cosmic navigation hazards, as analyzed in a July 2025 YouTube video by Dr. Becky. Pulsar timing arrays, refined in recent years, offer sub-millimeter accuracy over light years, but hardware failures remain a risk. Quantum error correction, part of 2025's quantum tech boom, could mitigate signal loss, sustaining life among the stars. Human factors and ethical dilemmas. The human element is perhaps the greatest challenge. Interstellar missions could last decades, requiring self-sustaining life support systems. Recycling waste into food, water, and oxygen is critical, as is growing food in space. Concepts like regenerative ecosystems or hydroponic farms are being tested, but scaling them for long missions is no small feat. Prolonged zero gravity also wreaks havoc on the human body, causing muscle atrophy and bone loss. Artificial gravity through rotating spacecraft could help, but it's never been tested on the scale needed for interstellar travel. Another wild idea, suspended animation. By placing astronauts in a hibernation-like state, we could reduce resource consumption and protect against the psychological toll of long missions. But inducing safe, long-term hibernation without health risks is still science fiction. The crew's survival will depend on technologies we're only beginning to imagine. In 2025, bioengineering advances, such as those in plant synthetic biology, could enable silicon-enhanced crops for better resource efficiency in space. Ethical issues arise with generation ships, where multiple generations live and die en route. The walk-wait dilemma questions whether to launch now or wait for better tech, potentially dooming early crews to obsolescence. The cosmic paradoxes that challenge our understanding. Latest insights. As we dream of exploring the stars, the universe throws curveballs that challenge our understanding of reality. Take Olber's paradox. If the universe is infinite and filled with stars, why is the night sky dark? The answer may lie in the universe's expansion, stretching light from distant stars into invisible wavelengths, or in interstellar dust blocking their glow. A 2024 Orbital Today article reaffirms this, noting redshifts make distant light to faint. Then there's the horizon problem. Why does the cosmic microwave background radiation have a uniform temperature across vast distances that shouldn't have been in contact? Cosmic inflation, a rapid expansion in the universe's infancy, might explain it, but it's still a mystery. The flatness problem questions why the universe's geometry is so perfectly balanced, potentially resolved by dark energy's repulsive force. The information paradox debates whether black holes destroy information, challenging quantum mechanics. New 2024 research suggests quantum correlations in spacetime could preserve it, leaving gravitational wave signatures. The negative time paradox from quantum mechanics, highlighted in a 2025 BBC article, shows light can exit materials before entering, defying causality. Dark matter and dark energy remain elusive, comprising 95% of the universe. Bentley's paradox notes discrepancies in galactic rotations, solved by invoking these invisibles. A 2025 New Space Economy post unpacks these conundrums, suggesting modifications to dark energy properties or new particles. The entropy paradox wonders why the universe is ordered despite thermodynamics predicting disorder. Solutions include the arrow of time in open systems, or emergence theory where microscopic chaos breeds macroscopic order. The monopole paradox questions missing magnetic monopoles, possibly diluted by cosmic expansion. In 2025, the UN's International Year of Quantum Science spotlights these paradoxes, with symmetry-based solutions emerging from conferences like Symmetry 2025. A Vanderbilt physicist resolved the grandfather paradox for time travel, showing no logical contradictions. The search for alien life. Are we truly alone? Fermi Paradox updates. Perhaps the biggest question of all, are we alone? The Fermi Paradox asks why, in a galaxy with billions of stars and planets, we've seen no signs of intelligent life. In 2025, 75 years after Fermi posed it, Harvard's David Charbonneau says we're closer to answers, with JWST data hinting at biosignatures. New theories abound. One suggests aliens are off the grid, avoiding energy-intensive expansion to evade detection. Avi Loeb advocates expanding searches beyond radio signals to artifacts in our solar system. Stephen Webb's book lists 75 solutions, from rarity of life to transcension into higher dimensions. A quantum solution proposes aliens use interstellar quantum communication, undetectable by us. The Great Filter Theory warns of barriers like nuclear war or AI gone wrong. Brian Cox discusses it in a 2025 video, linking to humanity's survival. A neo-Kantian view claims everybody is already here, but perception limits us. Reddit theories suggest mind uploading onto spacetime. Planetary Society updates emphasize the paradox's core. Conditions for life seem common, yet silence prevails. The Dark Forest Hypothesis. Chilling explanation or flawed theory. The Dark Forest Hypothesis, inspired by Liu Cixin's novel, offers a chilling answer. Advanced civilizations may exist but remain silent, hiding to avoid detection by hostile rivals. Like hunters in a dark forest, they stay quiet to survive, wary of revealing their position. This chain of suspicion suggests that broadcasting our existence through radio signals like the 1974 Arecibo message could invite danger. Stephen Hawking himself warned that such signals might attract unwelcome attention, likening an alien visit to the colonization of the Americas, with disastrous consequences for the natives. In 2025, the hypothesis faces scrutiny. Noah Smith calls it absurd, arguing rational aliens wouldn't default to destruction without evidence of threat. A Reddit post critiques its assumption of unsolvable lightspeed limits, suggesting advanced tech could enable peaceful contact. National Geographic explains it as one of many Fermi solutions, but opponents like those in Medium articles note it ignores potential for cooperation. A YouTube video from May 2025 outlines why it's unconvincing, citing inconsistent alien behaviors. And explores its terrifying implications but questions if all civilizations are predatory. Game theory analyzes. like in the monist, highlight Hobbiesian traps but propose alliances. ResearchGate's 2025 paper describes the universe as a silent forest, but critics like Dominic Butts argue it assumes unified, eternal behaviors in civilizations. Orbital Today debates if it's fiction or reality, noting humanity's signals might already expose us. Big Think's July 2025 video reinforces the fear but suggests benevolence could prevail. A Springer article ties it to extraterrestrial hypotheses, warning of existential risks. Facebook discussions link it to three-body problem, questioning invasion motives. PHYS.org notes Fermi's paradox evolves, with dark forest as a pessimistic view. Silicon-based life. Beyond carbon, new frontiers in 2025. But what if life isn't carbon-based like us? Silicon-based life, thriving in extreme environments like Venus's sulfuric acid clouds or Titan's methane lakes, could exist. Silicon, like carbon, can form complex molecules, but it's less versatile, struggling to bond in water or at moderate temperatures. While carbon forms the backbone of life on Earth, silicon might dominate on planets with high heat, pressure, or exotic solvents. Imagine organisms made of living stone, as depicted in sci-fi, or microscopic diatoms with silicon shells thriving in alien oceans. The possibilities are endless, but our technology limits our ability to detect such life. 2025 research advances this idea. An astrobiology article hypothesizes silicon-based autotrophic virus-like particles. A study on Io, Jupiter's moon, suggests its volcanic, sulfur-rich conditions could support silicon biochemistry. Earlier work from 2016, evolving enzymes to incorporate silicon, paved the way, with Caltech's 2016 breakthrough showing living organisms making CC bonds. ResearchGate's March 2025 analysis explores silicon biochemistries. MDPI reinforces silicon's frontier in synthetic biology. HPLC 2025 previews micro-nanofabrication for analytical chemistry in life sciences. Notre Dame College argues for silicon valleys on other worlds. Wikipedia lists hypothetical biochemistries, including silicon dioxide forms. Live Sciences 2017 findings, updated in 2025 context, show evolution incorporating silicon. RSC's review on silicon anodes ties to energy but analogies to life. A May 2025 ResearchGate paper evaluates silanes replacing hydrocarbons. CAS's 2025 trends include metamaterials, potentially mimicking silicon life structures. Advances in silicon anodes for batteries highlight material versatility. Boreum's July 2025 paper discusses nanocomposites for silicon-based systems. Game theory sheds light on the dark forest hypothesis. If an advanced civilization detects our signals, they face a choice: attack, stay silent, or seek friendship. Attacking might secure resources but risks retaliation if we broadcast their location to others. Staying silent avoids conflict but gains nothing. Friendship could lead to mutual benefits, like sharing technology, but trust is a gamble in a universe driven by survival. For Earth, sending signals is a high-stakes bet. Do we risk exposure or embrace isolation? Some argue we've already been broadcasting for decades, so the cat's out of the bag. Others, like SCTI's Douglas Vakic, believe openness could lead to alliances with benevolent civilizations. Expanding with 2025 insights, Medium's game theory analysis suggests peaceful coexistence is possible if incentives align. The Modest paper models post-contact scenarios, advocating diplomacy to escape destruction. Interstellar travel and the search for alien life demand global cooperation, massive investment, and bold innovation. Space mining extracting resources from asteroids could fund missions, while 3D printing in space could reduce launch costs. Generation ships, carrying entire societies across centuries, offer another solution, though they raise ethical questions about crews living and dying in space. Should we launch now, knowing future technologies might surpass us, or wait for breakthroughs that could make travel faster and safer? This walk-wait dilemma forces us to weigh progress against sacrifice. In 2025, WEF's transformative tech list includes AI for mission planning and sustainable space habitats. LEAP predicts private sector growth driving interstellar prototypes. The universe is a vast, mysterious tapestry woven with paradoxes, possibilities, and unanswered questions. From the dream of interstellar travel to the search for alien life, humanity stands at the threshold of discovery. Will we find silicon-based organisms on distant worlds? Will we uncover the truth behind the universe's mysteries? Only by exploring, questioning, and daring to dream will we find out. If you're as fascinated by the cosmos as we are, hit that like button to show your support. Share this video with friends who dream of the stars, and subscribe to BrightBoundX on YouTube for more mind-blowing journeys into the unknown. Click the bell icon to stay updated on our latest cosmic adventures. Let's explore the universe together. Join the BrightBoundX community today.